Okay, students, let's start with the second video of our physics, that chapter 2. The last video I have sent you the numerical, that was we have the charge plus q here and a charge minus 3q here, and there's a distance that is x, and I've given you find the electric potential for at any point that would be 0. So I have given you the options, that is a by 2, a by 4, a by 6 and a by 8. So what we have studied, that v is equals to at any electric potential due to any point charge would be k into q divided by the distance between that point. For example, I take this point P, but at P electric potential is 0. So for this distance I have taken the x, so it would be automatically, it would be sorry, this was a and this was x in your numerical, so it would be a minus x. So potential due to this charge would be k due to this charge, which would be k into plus q. You have to take the magnitude, k into plus q divided by x, and potential due to this charge would be k into minus 3q divided by the distance, that would be a minus x. And we all know that is electric potential is additive in nature, so it would be v is equals to v1 plus v2, that is k into q divided by x plus k into minus 3q divided by a minus x. It would be kq into 1 by x minus 3 over a minus x. And I have told in the numerical that they'll find at that point that electric potential would be 0. So this thing would be 0. If you calculate this, you will get this part, that is this thing would be 0, and it would be 1 by x minus 3 over a minus x, and it would be 1 by x. Here this will be minus x, and you can say that 3x is equals to a minus x, or 4x is equals to a, and x is equals to a by 4. So your option number B is correct, that is at a by 4 distance electric potential would be 0 from here, and from if you want to calculate from this point, it would be a minus a by 4. That is, if I said from plus q, from minus 3q, it would be 3a by 4. So this was your numerical which I was given you. So our second topic would be electric potential due to a dipole. We have discussed in the first chapter very considerably, that is P is equals to Q into 2L. This is your electric dipole, and it always act in a pair. For example, I have taken these two charges minus q, and here is a plus q, and there is a distance 2a, total distance is 2a, and this is a and this is a, and at any point P I want to calculate the electric potential due to these dipole. So we have to calculate the electric dipole due to these point charges, that is minus q and plus q. We have discussed the formula, that is what we are doing, this v is equals to kq divided by the distance. Electric potential due to any charge would be this. So if you have to take the charge for plus q, for example, I have taken from this center is O, and from center and P there is a distance r. So for plus q charge, I can say that let it be for plus q charge, it would be k into q divided by the it would be plus q, and distance. What would be the distance for the plus q? It is r, and this is a, and I think it would be r minus a for the plus q charge, and potential due to minus q would be k into minus q divided by distance would be, this is r and this is a. See, once again, this is r and this is a. It would be r plus a. This is r and plus a. So we have to add these two charges. It would be V plus Q and plus V minus Q equal to total electric potential, that would be K into Q divided by R minus A plus K into minus Q divided by R plus A equal to total potential. From here you can say that you can take LCM, or if you take KQ common, it would be 1 over R minus A plus 1 over R plus A equal to this. So it would be K into Q, R minus A, R plus A would be the LCM. It would be, sorry, this would be minus, because here you have minus. So 1 over R plus A minus R plus A is equals to V. From here you can see that it would be K into Q over R plus A minus R minus A, and in denominator you will get R square minus A square is equals to V. Here you can say that, oh, it would be sorry, in previous page it would be R minus A here, so it would be minus R and plus A. So minus R and plus I cancel out, so it would be K into Q into 2A divided by R square minus A square equals to V. And you all know that Q into 2A is a electric dipole, so it would be Q into 2A is electric dipole, that is P. So you can say that it would be K into P over R square minus A square. That is the result for your, in your books you have written like this, K you all know that is 1 by 4 pi epsilon naught into P over R square minus A square would be the electric potential. And for second case, we say that if R is very greater than A, or R square is greater than A square, you can say that potential would be 1 by 4 pi epsilon naught, and A would be 0, that is, so it would be P over R square. This is the electric potential due to the dipole. You have to learn these two formulas. So our next topic is electric potential at an equatorial point of a dipole. Electric potential at an equatorial point of a dipole. So it would be like this: minus Q charge and plus Q charge due to dipole, or due to equatorial point. Always take these points. This is point P, this is 2A, and this is R. So according to Pythagoras, you can say that it would be R square plus A square, and this was also R square plus A square. It is very simple. You all can say that its answer is 0. Why? You can see that according to this charge, that is potential would be KQ by they both have same distance and same magnitude but opposite magnitude, that is K into minus Q divided by R square plus A square is the electric potential due to minus Q, and according to plus Q it would be KQ over under the root R square plus A square. When will you add this? This is minus and this is plus, they will cancel out and the potential would be 0. That is electric potential at an equatorial point of a plane of a dipole is always be 0. So this was about your dipole part, and we will study next things in your next videos. I hope you will understand this and try the numericals, and I will send you the numerical part.